Can you see a picture of me now on the slideshow?
Yes.
Okay. Sweet.
Yes.
Awesome.
Yes.
All right. Now I'm going to disappear. And I'm going to start the slideshow, and then I'll do some examples. Okay. So today, this word looks very similar to the word that we had yesterday. And the word yesterday was molarity. Today's concentration calculation is called molality. Why do chemists do that to you? Probably to confuse you so you'll miss them, would be my guess. Molality is very similar to calculating things in molarity. So when we calculate molality, the top part is the exact same as molarity. It's the bottom part that's different. So molality is moles of solute, just like yesterday, but instead of liters of solution, we're going to just divide by the kilograms of solvent. And for us, most of the time, the solvent is water. So if you have the moles of solute and you know how many kilograms of solvent you have, then you can calculate molality. Why is molality a thing? It's used in different measurements of things in chemistry that you guys haven't learned about yet. If you take Chem 2, you will. The labels for molality are moles per kilogram, which I never use hardly. I usually, because I'm lazy, put a little m. So yesterday's label was a capital M. Today's label is going to be a little m. Is that confusing? Sure is. Okay. If you see it in a textbook, usually it's a little m that's italicized. So little m, or if they're describing the solution as kind of using an adjective to describe the solution, they would say molal. So like a 4 molal solution, which is a weird word and kind of weird to say. So that's molality. Okay. We will do an example of molality right now. So we have a solution we're trying to make. We want to quantify. A lot of times with molality and molarity, there's some extra steps that aren't directly in there that you have to deal with. So we're going to find the molality of a 38 gram solution of sodium chloride. So 38 grams is going to be our solute. And we have 650 grams of water. Okay, now molality is a combo of moles and kilograms. And you'll notice here, we don't have moles and we don't have kilograms. What you have to do with all these solution problems is identify who you think the solute is, the thing being dissolved, and who you think the solvent is, the thing that's doing dissolving. To calculate molality, we need moles and kilograms. Notice, we don't have moles, we don't have kilograms, we have to deal with it. That's how these professors and these teachers make this stuff a little bit harder than it actually is. It's just extra steps that we can screw up. So, something that you guys are going to want in your notes is that 1 kilogram is equal to 1,000 grams, which at this point, you guys probably knew that, but let's throw it down there, okay? So to do the molality, we got to do 2 conversions. I'm going to do the first one with the kilograms. So I know that if I convert from grams to kilograms, I'm going to divide by 1,000. Okay, we could do choo-choo tracks. We can move the decimal 3 places. It does not matter. I'm going to be a lazy turd and put 0.650 for my kilograms. Okay, so that's our solvent. That's going to be the part that goes on the bottom here. 0.65, and I think it's only 2 sig figs, so whatever. We'll just leave it 0.65. This part we have to do a conversion. I'm going to help you out and just keep this quick for you. The molar mass of sodium chloride is 58 grams. 1 mole sodium chloride. So we have 38 over 58. That's going to be the part that goes on the top. So about 0.66. Okay, so 0.66, or if you use 0.655, it doesn't really matter at this point. You're going to end up with the same answer when you round to 2 sig figs. Why am I rounding to 2? Well, that guy had 2 sig figs, and this guy had 2 sig figs to start off with. So my answer is 1.0 little m. That's how you do molality. very similar to molarity yesterday. Yesterday, if we did molarity and this was in milliliters, we convert to liters. Today it was in grams, we convert to kilograms. Whatever. Sometimes they are going to be in moles and kilograms, and you can just do the step right here. But I kind of started with the harder ones, the ones that require a little bit more work. Okay, so that's molality. That's pretty much it for molality. Are there any questions on how I got some of these magical numbers here? As I'm erasing. Okay, your silence means no, or you're all on mute. Or you're playing Xbox right now. Just have this on to appease your parents. That's cool too, right? Okay, so this is kind of the one that everybody screws up. So I saved this the best for last. And this one is different than molarity and molality in that we don't have to deal with any moles. Percent solution by mass. If you look around your house, you are going to probably see anything that's a solution, so like hydrogen peroxide, rubbing alcohol, things like that. You will see sometimes a percentage sign next to the chemical that is in the bottle or whatever, okay? And what that is a percentage of that chemical, usually diluted with water. There's two ways to do this: percent solution by mass, or sometimes chemical companies use percent solution by volume. We're going to stick to the mass just because we're used to mass in this, okay? So to calculate percent solution by mass, you're going to take the mass of the solute over the mass of total solution, and then you're going to take all that and multiply by 100 to make it a percentage. If you want to move the decimal 2 places, that's great as well. So it's mass of solute over mass of solution. Okay? I'm going to show you why people screw this one up. Okay? So I'll show you that in a little bit. Now, this is one of the things that people will screw this up. People will say, hey, if I take 15 grams of salt and I put it in 100 grams of water, shouldn't that be 15 divided by 100? It is not, and I'm going to show you why. The thing that people mess up is they will assume that the solution, which is the combo of everything, they'll assume that's the solvent. So another thing that you have to keep in mind here is a solution's mass is made up of two things. It's made up of the solute, but it's also made up of the mass of solvent, which, like I said, in most cases is going to be water. Okay, so I'll show you where people go wrong with this with a very easy example, just because it's off the top of my head right now, and I just know people screw this up all the time. I totally get it. Okay, so if I were to take 15 grams of sugar, okay, and I were going to put that into 100 grams of water, what everybody does wrong when it comes to percent solutions, is they do this. They do 15 divided by 100. Okay? That is not correct. The percent solution says it's the mass of solute, which is totally that, divided by the mass of the solution. That is just the solvent. So it's actually not 15 divided by 100 and make it a percentage. It's actually 15 divided by 15 plus 100, because you have to add everything up. The mass of the solution is actually 115 here. And then we would make it a nice percentage. That wasn't right. Even I screwed it up. Okay? So what you would expect to be 15% is actually about 13%. That's the thing everybody messes up. I'm going to make one small change to this problem that's going to make it much different. Okay? So let's say we take 15 grams of sugar and we dump it in enough water to make 100 grams of solution. All right? 15 grams of sugar, we're going to make 100 grams of solution. Well, right here, this shows me that that this is a little bit different because we have the 15 grams of solute, we have the 100 grams of solution. We find the percentage, it would be 15 divided by 100 times 100, or just move the decimal 2 places. That's a 15% solution, okay? Another thing you can find here is in this thing, if I wanted to make a 15% solution of sugar and I wanted 100 grams of it, I can kind of figure out how much water I would need, because the mass of the solution is equal to the solute plus the solvent, which, like I said, in most cases is going to be water. I'm probably just going to keep it water for us just because it's easier. So 15 plus what number would equal 100? 15 plus 85. So we need 85 grams of water. This one is the one that just gets people, because they just, I don't know, get on autopilot and you start rolling, okay? So let's look at an example of percent solution by mass, okay? All right, we'll look at a couple. So we're going to find the percent solution. We're going to take 455 grams of glucose, and it's dissolved into 889 grams of water. Okay, so what you have to ask yourself is, I'm going to roundabout have 3 things, okay? I'm either going to have the solute, the solvent, or the total solution, okay, given to me directly in the problem. So what I have to do is kind of have to identify what each part is. I would say that the glucose, since it's being dissolved in the water, the glucose is going to be our solute. And since water is doing the dissolving, it's going to be the solvent. So if we were going to do this problem, we would take 455 divided by not 889. We want to know the total solution. So we take 455 plus 889. This gives me a total solution of 1344. Now we're in business. 33.9% solution. Okay, if you wonder why I got 1344, I simply added the solute to the solvent to get the solution. Okay, so that's an example of using and having to add the values up to get the solution. The next example we're going to do, you'll look in the problem and you'll notice it's a little bit different. So find the percent solution. You take 225 grams of solute and you dissolve it to make 755 grams of solution. So once again, kind of nice of them here, because instead of telling you that they're dissolving it in water, they're just saying, hey, dude, your solution is 755. So you have 225 grams of solute. We have 755 grams of solution. We're going to find the percentage by taking 225 divided by 755. Make it a percentage. Call it a day. 29.8% is what I get. All right. So today, molality, very similar to yesterday's molarity, and then this weird percentage one kind of has a lot more going on with it. All right. Okay. Does anybody have any questions?